One of the first mathematicians in history was a Greek philosopher named Thales. He was from Asia Minor at a place called Miletus and lived around 624 BC and 54 BC. Thales contributed to geometry early on and was one of the first individuals that a maths concept was named after from the age of mathematics. His theorem was titled the Thales theorem. He played a major role in the research of geometry and is known as a progenitor for the geometry of circles. The history behind Thales is not very clear. Many people claim he is Greek and others believe he was Phoenician. He never married but adopted a child. On top of geometry, he had a large fascination with engineering, astronomy, and philosophy. He created the first theories around circles, despite the Egyptians creating the wheel and circles' properties being well known. He used geometry as a way of determining the distance ships were away from shore, and also the height of pyramids. Thales discovered the following. Any triangle inside a semicircle will be right-angled. Circles are bisected by their diameter. Angles inside triangles with opposite sides equal in length are equal. Angles opposite each other formed by intersecting straight lines will be equal. Triangles are determined if their base and two angles at the base are given. Thales discovered that no matter where point B is placed on the semicircle, the angle ABC will be a right angle. This means that you are able to use the Pythagoras theorem to calculate the side lengths of the triangles as the triangle will be a right-angled triangle. You are then also able to calculate the sine, cosine, and tangents of the triangle as it is also a right-angled triangle. This could have been used throughout history to calculate measurements for buildings, structures, and even wheels. This theorem can be utilised when looking for the diameter and also the middle of a circle. To find the diameter, you need an object with a right angle. You must place the right angle anywhere on the edge of the circle. The objects will cross the edge of the circle 3 times. To find the diameter, you draw a line from the 2 places that the object intersects the circle that aren't the right angle. I've put a dotted line to show this. The distance of the dotted line will be the diameter of the circle, and the middle of this dotted line will show you the middle of the circle. You can take this further and find another right-angled object and repeat the previous steps. Where the diameters intersect in the circle is the middle. So, it intersects the circle there and there, so therefore this will be the middle of the circle. This may have been used in history when they were making wheels and putting the beams in to add structural stability. Thales discovered that the angles inside of a triangle, opposite 2 sides of equal length, are equal. We call these triangles isosceles triangles, and they are very important in geometry. By knowing that all angles in a triangle must add up to 180 degrees, Thales' theorem uncovered that you only need to know one angle in these kinds of triangles to be able to find the rest of the internal angles. So I've labelled this triangle just to give an example and show what these triangles look like. So these sides are of equal length. They're around 20 centimetres each. By knowing these are 20 centimetres each, we can also know that these 2 angles, which I have labelled as beta, are equal. So if I know this angle, then this angle will be the same as that. And then to find this last angle, I'll just need to do 180 minus these 2 angles. Or say if I knew this angle, I'd do 180, take away whatever this angle is, and then divide that by 2, and I will know these 2 angles. Thales was the first mathematician to discover that a circle is bisected by its diameter. Earlier in this presentation, I demonstrated the ways that Thales' theorem helps us find the diameter of a circle. Therefore, with the knowledge of how to find the diameter combined with knowing a circle is bisected by its diameter, gives individuals the ability to split a circle in half. Without Thales' theorem, we would not be able to calculate the area of a circle and also a semicircle. To find the area of a circle, you need to know the radius, which is half the diameter. By using Thales' theorem, we can calculate the diameter of any circle using right-angled objects, as demonstrated previously. Then we can take this measurement of the diameter, cut it in half, and use the equation pi multiplied by radius squared. Thales discovered that any circle is bisected by its diameter. This gives us the knowledge that half the area of a circle will be the area of the semicircle if the circle is split into equal halves. I also just quickly wanted to touch on Thales' theorem that opposite angles were formed by intersecting straight lines are equal. I've just shown 2 examples of this to prove it. So these are 2 straight lines, and I've drawn there's 2 angles there. These 2 angles, beta, are equal, and then also these 2 angles, alpha, are equal. So if you added these two angles and these two angles, it would be 360 degrees. The theorems Thales developed had a massive influence on the past, present, and future of geometry. He found many things, including how to calculate the diameters and middles of circles. To bisect a circle, all you need is that diameter, and if you cross two straight lines, the angles opposite each other will be equal. These theorems play a major part in the development of other mathematicians' theories throughout history. Without his knowledge, we would not have such advanced abilities in mathematics and geometry as we do today.